I haven't posted any videos for a while now. I've been fairly busy working my way through the pile of repairs that's built up, and it does take a long time to make these videos. It makes the repairs take 4 or 5 times as long, and so I just needed to get the pile of repairs down a little bit and get the machines back to the owners. But I've worked my way through a lot of them, so I'm getting fairly close now to be able to get back onto the videos. And got some interesting ones coming up. I've got a lot more work to do on the Z80 project. I've got quite a few videos to post on the 9845B that I started working on over a year ago now, and some interesting upgrades and repairs on that still. Got a power supply to repair on it, and so I'll be posting some videos on that. And the next step with the Z80 project is I'll be designing a switch mode power supply from scratch for it. So it'll be multi-rail supply that we'll need for that particular project, and I thought it would be interesting to develop one from scratch. I could just buy one, drop it in, but going along with the theme of the project, I thought it would be quite interesting to design a switching power supply from a blank sheet of paper. So that will be a series of videos in its own right. But I decided to post this particular video just out of interest, and if you've been watching my channel for any length of time, then you'll know that I've been a bit of a fan of cheap Chinese equipment for a while, mainly because although quite often when you get it, it's in a bit of a state and needs a lot of work, quite often it's a good basis for ending up with quite a nice piece of equipment. So for example, I bought a cheap CNC 3.5 axis mill about 15 years ago now. It was quite cheap for what it is, but it needed a lot of work before it was really usable. But it's been working well ever since. A very nice machine, and I've got quite a few bits of equipment like that where they started life as a piece of cheap Chinese equipment, needed some work, but I ended up with quite a nice result. Now unfortunately, I think the Chinese are going a bit beyond what's acceptable, and they're becoming their own worst enemy. And it's really because of the dishonesty that they're exhibiting. It's not really the product itself, it's just how dishonest they're being in the way that they're marketing them and trying to sell them, and they're being very deceitful, and that's starting to grate on me a bit. And I thought in a small way I'd push back a little bit against that in this particular video. So I needed a small battery powered tool, and I bought this off eBay a week or so ago. And I knew it was cheap. I knew it wasn't going to be a particularly well manufactured piece of equipment. It's reasonable for what it does, but it's battery powered, and it came with this battery. And firstly, it says lithium ion on it. It's not, it's a lithium polymer, it's different. And the other thing to notice with this when I open the box is that it doesn't anywhere on this say what the capacity is. It also doesn't say what the voltage is, which you might think is a bit strange considering what you're now looking at. So it hasn't got the capacity, so that really makes it illegal to sell in this country. It's supposed to have the capacity and also the type of battery it is, and neither of those are correct. So although here it says 48V, well, you'd kind of assume it's a 48 volt battery. What I noticed most when I opened it, and it's not something you're going to be able to really appreciate on the video, is this weighs almost nothing. And I've shown in previous videos that really the capacity of a battery like this is directly related to its weight. The heavier it is, in general rule of thumb, is the more capacity it has. So firstly, this is a 21 volt battery. Actually 18 volt is what would normally be referred to as 5-cell battery pack. The 48V, as far as I can tell, they've put an H on the end, and that's to make it a model number. So this is a model number 48VH battery pack. It's not the voltage, it's not a 48 volt battery pack, so that's deceitful in itself as far as I'm concerned. But like I said, it's the weight that's the interesting thing. So I had a very similar tool, almost identical, and it came with this battery pack. This is now, as you can see, quite old. But this is a higher capacity battery pack than this one, and it's the same voltage. So what I thought would be interesting is just to, we'll have a look inside it in a few minutes, but we'll start by weighing this. I'm not quite sure how well the display on this scale will come out on the camera. Sometimes it seems okay and other times you can't read it at all. So I will read out what it's saying. It's going to read in grams. So we'll start with this one. So I'll put this one on here. 299.6 grams, so just under 300 grams. Which is, it might sound a lot, but for a battery of this size that's actually extremely light. If I put this one on there, 300 and just under 314 grams. So this is actually heavier despite being a much smaller battery pack. But this again, it's a cheap Chinese one. Had this a few years now, but once again I haven't peeled the stickers off. It doesn't say what the voltage or capacity is, so technically it shouldn't be sold in this country anyway. If we now go to a more professional type battery pack, remember we were just over 300 grams. This is in theory same capacity, same voltage, 350 grams, so it's significantly heavier. We'll try another professional battery pack, same sort of capacity, 350, just under 355 grams, so quite a bit heavier. And if we now go to the nearest equivalent for this size of pack, like I said, this is a 21 volt pack, so we'll have banks of 5 cells in here. And same here, the only difference with this one is there are 2 banks of 5 cells, which in theory there should be in here. So we'll put this on. So it's overloaded. This is a 500 gram scale. So this weighs over 500 grams, and yet in theory it should be very similar in weight to this. So it's probably twice the weight, which made me start being a bit dubious as to what was actually in here. So I think what we'll do is we'll open this up. Now one of the reasons I'm doing this is you're probably aware that there's a flood of electrical machines, let's call them, flooding into the UK at the moment, and they all use the same types of cells that are in these battery packs. There's just many more of them, usually several thousand cells in each of these machines. But if we're going to see the same type of thing from China that we're seeing in the differences between battery packs like this, then we're going to have a major problem over the next few years. So what we'll do is I'll get this opened up, we'll have a look inside and see what's actually in here. Get the last screw out. Okay, and we'll take a look inside. It's not a bad quality plastic, by the way, so it's not too bad in terms of the way it feels in stiffness and general build, but I suspect what's inside is not quite what we'd ideally like. So, okay, we have a charge control, discharge control circuit board. Quite a nice layout. It's got a proper frame inside to support the cells, so that's quite good. Lift this out, and as expected we can see that firstly this weighs almost nothing, and the cell, I'm just trying to see the cell type, Hongli, never heard of that one, but it does not give a capacity anywhere, so it's not saying what the capacity is. But as you can see, it's only half populated anyway, so that would explain why it's so light. What I'm going to do is, just to see what the capacity of this is I'm going to put it onto a charger, discharger. So I've got a few of these. I fly model helicopters, electric helicopters, and so I have quite a few battery packs that I charge and discharge on a regular basis. So we'll put it onto this. I'll put it through a full discharge and charge cycle, and we'll try and get some idea as to what the capacity of this is. Now I've done the same thing with this pack already, and this is rated as a 2 amp hour pack, and it came out as 2.08, so it's slightly over 2 amp hours, and that was at a 1C discharge rate, so a 2 amp discharge rate. So on the assumption this is supposed to be the same, I'm going to run this 2 amps as well, and we'll see what its capacity is. Okay, I don't know if you can see the display or not. 2 channels, so it's just the left hand channel we're interested in. So I've got this set up for a single discharge charge cycle. So it's currently just started, so it's going to discharge the battery pack to 3 volts per cell. and then it's going to charge it up. It's doing this at a 2 amp rate, and as I say, it's going to discharge it, wait about a minute, and then it's going to charge it back up, and it will give us the capacity as it goes. So currently it's showing that we're 24 milliamps. That's kind of irrelevant. I don't know how charged this is. I haven't charged it up yet, and we'll leave it and see what we end up with once the cycle's finished. It'll probably take about an hour and a half, 2 hours to fully cycle, so we'll leave it, come back and see what the results are. Okay, well, it's about 5 minutes later, and the battery voltage, the pack voltage, dropped almost immediately to 15 volts. I was drawing 2 amps from it, and it may just be that it wasn't charged up at all, so we'll give it the benefit of the doubt. It's now going to rest for 1 minute, and it will then start charging again at 2 amps. That will obviously ramp down once it gets near to charge, so it'll go from constant current to constant voltage once the battery voltage or the pack voltage reaches a certain value, and it'll then try and balance it as well. So it shouldn't take too long. It's only taken a few minutes to discharge, which is a bit worrying. It should have a bit more charge in it than that, but we'll see how it goes. It's just about to start charging. So it's gone into charge mode now. You get a good idea by how quickly the battery pack voltage ramps up as to how well it's accepting charge, and this is now already up at 19 volts, which is a bit concerning. I wouldn't have expected it to rise quite that quickly, but we'll leave it going, see what the capacity is. I'll leave it on capacity, and we'll see what it manages to get to. So it's been running for about 15 minutes, and it's just gone into constant voltage mode. It's got to 21 volts, and that's the peak voltage limit for this battery pack. One thing that is noticeable as well with these cells is, if you look at them under the thermal camera, you can see that one cell in particular is getting very much hotter than the rest. They are on average around 20.5 degrees centigrade, but that one is up near 40 degrees centigrade. And I've checked the voltage across them all, and they're all about the same, so that cell might not be too healthy. Might recover after a few cycles, but generally this type of battery doesn't recover. It just gets worse and worse, and this is one of the dangers of these cells. If you've got thousands of them all closely packed together and one fails, it tends to take out the rest. And this is the kind of effect you get, and this is just at 2 amps. If you're drawing a lot of current through these things, then you do need to match them fairly well. And if we look at the reason behind this, if we come down, so far we're at just over half an amp hour, about quarter of the capacity, what I've expected with a battery pack like this. But if we scroll down, we can look at the internal resistance of the battery pack, and it's 260 milliohms, which is fairly poor. That's quite a high resistance. So if you're drawing several amps from this, then obviously the pack's going to get quite hot. The board itself is fine, the control board, it's quite cool, but the cells, or one of the cells at least, is getting a bit on the warm side. So we'll leave it running, see what the peak capacity is, and we'll go from there. In fact, what I'll probably do is wait until it gets down to maybe 0.1 amps. That's fairly close to full charge, rather than waiting another hour for it to finish topping off, and then we'll see what the capacity is and go from there. Okay, we're just on 48 minutes into the charge cycle, and we're just over 1 amp hour. It's actually better than I expected, but it's still only about half of what I would really have expected from a battery pack like this. So I've checked the tool this goes into, and it draws about 6.2 amps when it's running. Okay, the battery pack is of course fully charged, so what I'm going to do now is try to discharge it at a rate in line with what the tool would use. So the tool runs at about 6 amps. So I'm going to connect this to a electronic load. We'll set it to 6 amps, and we'll see how long the tool would run for at that rate. I suspect it's not very long. I said I had an equivalent one or a very close match to the tool with a smaller battery pack, and that tool lasts for about 20 minutes when it's running. So we'll run this one up, see how long it lasts, and see if the pack's actually value for money at all. Now, the pack has got fairly hot during this process. I'm going to let it cool down for about an hour just to give it a fair chance, and then we'll get it connected to a load and see how well it does. Okay, I've got the battery pack connected to an electronic load. I've dimmed the lights so that there's less flicker on the electronic load display. I've got the load set to constant resistance. That's more along the lines of what the tool would do if we had this plugged into the tool, so it should draw a current that's more in line with what the tool would do. The current's going to start dropping as the battery discharges, and that'll give us a more realistic time. I've got the stopwatch ready, so we'll get this running and start the stopwatch, see how long the battery pack lasts. So as you can see, we've started off near 100 watts, little under 6 amps, so the battery pack terminal voltage has dropped very quickly due to the internal resistance when we're drawing current, of course, but we'll see how long this runs for. As I said, I did this same test with the other battery pack and it lasted, I think it was 19.2 minutes, just over 19 minutes, so we'll see how long this one runs for. We're just coming up to the first minute now. Okay, well, we're just over 2 minutes in and the battery pack voltage is down to 15 volts. Now that's at the load. I haven't used the remote sensing. So at this current we'll get about half a volt drop in the leads. So when it gets down to 14.5 volts I'm going to stop the test, and because otherwise I could damage the battery pack. So we'll leave it running until we get to around 14.5 volts. And then I'll stop the test and we'll see how long it lasted. Okay, I'm going to stop the test there, mainly because the cells are up near 80 degrees centigrade and I don't want them bursting in the lab. So turn the light back on. So the high temperature was of course down to the high internal resistance. So they lasted about 6.5–7 minutes, about a third of the time of the other battery pack, which was also a cheap Chinese battery pack, but clearly is much better than this. And but it's about 10 years old, and this does seem to be what's happening recently, that we do seem to be getting a lot of very low quality cells coming into the country, and these are now really hot, so I'm going to put them somewhere to cool down. What I'm also going to do is run them through a few charge discharge cycles at around 2 amps to try and get some idea as to their true capacity if you were to run them in something that drew less power, and see what we get. That'll take a few hours, so I'll come back once that's done and let you know the results, but for now this needs to cool down quite a bit and hopefully it will be okay. Okay, well, it's actually the next day, and this was left running doing charge discharge cycles overnight. Did 6 in total, and the average capacity I was getting during discharge at 2 amp rate was around 520 milliamp hours, so about a quarter of what I would really expect. Now, what I said at the beginning of this video was quite often you can get cheap Chinese equipment that is a good starting point for building something better or just improving it, and I could of course now use this. It only cost me a few pounds. I could now use this to make a much better pack just by replacing the cells and I could even expand it into a higher capacity or higher voltage pack. So it could have uses. I doubt I'll do that. It was only really meant to be used for a single job, which I still have to do yet, and then I'll probably dispose of it. But as I say, my main concern here is that the number of devices we're getting coming into the country that use these same types of cell, and the way the cell capacity is dropping rapidly as time goes on. I'm not sure how useful the devices will be that are currently being imported, but I guess only time will tell. But my main gripe with this is the dishonesty of the way these devices are being sold. If they were honest and just advertise what they're selling, I wouldn't have much of an issue with it. But when you see something like this, you expect better. Now, like I said, they're only selling it for a few pounds, but I don't think that's any excuse to try and fool people. Just put on it what it is, and people will probably still buy it. But when you do this, you're going to alienate possible customers.